Guys, good afternoon. Welcome back. This is the teacher Miguel again. And today we're going to work on this reading lesson and is from your chemistry book. And the topic is the chemical reactions. The chemical reactions. So let's start. But first, we are going to check the vocabulary. We have here the vocabulary or the keywords. We have activation energy, that is the minimum amount of energy required for a chemical reaction to occur, and the amino acid is here. It's a naturally occurring chemical substance that combines with others amino acids to make proteins. The catalyst is a substance that enables a chemical reaction to happen more quickly or with less energy. The chemical reaction, that is a process in which one set of chemical substance change into another. Combustion, that is the chemical reaction in which substance combine rapidly with oxygen and with oxygen and to produce light and heat. And the product, that is a substance formed during a chemical reaction. And we have reactant, that is a substance that reacts with another during a chemical reaction. And we have the reaction rate, that is the speed at which a chemical reaction takes place. So let's start with the reading lesson with this topic, that is the chemical reactions. It's a chemical reaction. So the chemical reactions. The key concept is the chemical reaction are occurring all the time. The chemical reactions take place when two or more substances interact and their chemical bonds break apart and reform. Many chemical reactions are very useful or even necessary for life or on Earth. Energy change always accompany chemical change. The energy is needed to start reactions by breaking moleculars and bonds. Every day, the chemical reactions. The matter around you change all the time in several ways. For example, think about all the change the occur in food when you are preparing meal with your family. Food change size and shape while cooking. Ingredients like butter and chocolate melt, liquids evaporate and change into gas form, and different ingredients mix together and dissolve. Change in size, shape, form, or um, and different ingredients mix together and dissolve. Change in size, shape, form, or state are purely physical change, which means the ingredients keep the same chemical composition. Other change to food during cooking occur on molecular level, and the color of the food may change. The reaction of amino acids with sugars, for example, give cooked meat its characteristic brown color and new flavors, and odors may appear. These are examples of chemical change or changes. Many chemical changes in cooking make food more edible. As bread is baked, a chemical reaction releases carbon dioxide, which is then transferred in the structure of the cooked dough to make it light and fluffy. The chemical change or reactions occur when two or more substances or reactants interact. As a result, the moleculars of the reacting substance change, and so do the chemical formulas, and some chemical reactions break matter appeared. The chemical reactions that occurs when an electric current passes through water, for example, involve breaking water molecules down into its constitute hydrogen, and oxygen atoms. Other reactions combine matter. This is how, for example, rust form on iron nail when the nail is exposed to the oxygen and water. The chemical reactions happen around us all the time, and many of them are very useful. The chemical reactions brought about by cooking give food more flavor and make some types of food edible. And chemical reaction of combustion keep us warm. Generally, the electricity in power plants and power motors energize. Other chemical reactions, such as photosynthesis and respiration, are equally important but not quite as obvious. And without these chemical reactions, there will be not life on the earth. In fact, there will be not universe as we know it without physical change and chemical reactions. Elements would remain uncombined, so the world that we see around us would not exist. Not all chemical reactions occur at the same rate. Some, like explosions, happen very quickly, while others, like metal rusting, can take a long time, and the speed at which reactions turn into a product is known as the reaction rate. Many variables can affect the reaction rate, including temperature, the surface or area of the substance in the reactions, and the presence or absence of catalytic, such as enzymes. Energy change always accompany chemical reactions. Generally, initially, activation energy is required to make a reaction begin. Some chemical reactions give off energy, and other reactions need to absorb energy from the outside in order to continue. To keep studying with this topic, let's to watch a little video and we continue.
Hello, I'm Robert Kraft. This time we're going to look at the difference between chemical changes and physical changes. And this is an interesting topic because in elementary school and middle school, that can be a very confusing concept. By the time you get to high school chemistry, it's so simple and obvious that you don't even think about it. Why is that? Well, a chemical change is what happens when you change the chemical formula of a substance. So you're getting a different substance. Good example, if I give the chemical formula H2O, that lets you know that we're talking about water. Well, if we changed that chemical formula, if we broke it apart into H2 and O2, that's hydrogen gas and oxygen gas, that would be very different. We'd have H2O on one side of the equation, we'd have H2 and O2 on the other side of the equation. If the two sides have different chemical formulas, you've got a chemical change. That's simple. Well, if the two sides have the same chemical formula, it's a physical change. If I took some liquid water and froze it into solid ice, the liquid water is very different. It's got different physical properties. But if we look at the chemical formula, liquid water is H2O, the ice is H2O, same formula on both sides, it's a physical change. So once you get to the point of looking at chemical formulas and balancing chemical equations, the difference between chemical change and physical change is very, very simple. But until you get to that point, you have to rely on other indicators that aren't very reliable. You'll see lists of things like you can tell a chemical change by a change in temperature, or a change in color, by a change in the way it smells after the mixture has occurred, the formation of a precipitate, having solid things come out of a liquid, or formation of bubbles. Well, all those things are indications that you might have a chemical change. But all those things can also happen with physical changes. And you can have a chemical change that doesn't show any of those. A good example of that is the reaction of cornstarch to different liquids. And that's what we're going to do this time. We're going to look at a chemical change that doesn't show any of those indicators. To do that, I took some bottle caps. I used the cap off of a pill bottle. Into each of those bottle caps, I measured 0.05 grams, that's 50 milligrams, of cornstarch. We're going to leave the first one just as it is. The second one, we're going to add 2 milliliters of water. So I got my pipette that's measured off in half milliliters. We will get 2 milliliters of water. Add that. And then I've got a drinking straw that I cut to a point to use as a stirring rod to mix that up. And let's put the water over there. Put our stirring rod beside that one so we know which one we're using. For the third one, I have some saliva. I just spit into the little beaker a few times to get some saliva, and once again we're going to use 2 milliliters of saliva. Put that in there. Get a fresh stirring rod and get this all mixed up. Make sure you stir it enough to get rid of all the lumps. Everything mixed well in both of these. And then I've got another stirring rod to use for this one. And now we're going to let this sit here for 15 minutes. Okay, it's been 15 minutes, so now it's time to do our testing. And to test the cornstarch, we're going to use tincture of iodine. You can get this at the pharmacy or the grocery. It's used for treating cuts and things like that. Iodine reacts with cornstarch because cornstarch is actually a mixture of two different polymers. One's called amylose and one's called amylopectin. Both are long chain molecules that are made of smaller molecules called monomers. Each of these would represent a monomer. And for both of these substances, the monomers are made up of glucose. As long as that polymer stays as it is with all of those monomers still hooked together in the same way, then it would be a physical change. And we can test for that, as I said, by using iodine, because iodine is going to react with the amylose in that cornstarch. So if we take a drop of the iodine and put it in with our dry cornstarch, let's do 2 drops, and then give it a stir, we can see that it turns black. And that is an indicator for amylose. So we know that the amylose there has not changed. Nothing has changed there chemically. Now let's do the same thing with our cornstarch dissolved in water. Again, we will add 2 drops of our iodine. Give it a good stir. And again, we get that black color, showing us that the amylose has not been changed. So again, this is a physical change. And then we will do the same thing with the cornstarch dissolved in the saliva. 2 drops. Give it a stir. And this time, we didn't get that change. We got a little bit of dark. There's still a little bit left there that hasn't changed. But most of our starch, most of our amylose has been converted. This is a chemical change. The long polymer of amylose has been broken apart by the amylase, the enzyme in that saliva, into pairs of monomers. It's a smaller sugar called maltose. And so the longer that sits there, the more maltose molecules will be broken off. And so we wind up with a very definite chemical change. Even though before we added the iodine, you couldn't tell any change. It didn't change in temperature, it didn't change color, it didn't change in the way it smelled, it didn't form a precipitate, there weren't any bubbles. There wasn't any visible or perceptible difference between cornstarch in water and cornstarch in saliva until we did a chemical test with the iodine to see if that amylose was still there. Once we did that, we found that in the saliva the amylose was not still there, that it had changed. It had been cut up into those smaller sugars. So the next time you're investigating chemical and physical changes, keep in mind that while those other things are indicators that a chemical change may have occurred, the only way you know for sure is to look at the chemical formula, and you look at the equation on both sides to see if you've got the same formula on both sides. If you want to try this, get some water, some saliva, some iodine, some cornstarch, give it a try, learn about chemical and physical changes. Well, that's all for this time. Have a wonderful week.
Okay, guys, so this is the difference between the chemical and the physical change. So we have some exercise, but this activity we are going to do in class. Okay, we're finished for today. So thank you very much, guys, and I hope to see you in the class. Thank you. Goodbye.